Hi everyone, I'm back again with a new episode of my calculus video, and today I'm going to be talking about basic differentiation formulas and a couple of examples. So I'm going to start first with shedding more light on this. So the derivative of a constant is always 0, and we can actually trace this to this graph. Take for example, if I have an equation y equals 5 and I'm asked to graph this, I'm going to have a horizontal line, right? And the slope of a horizontal line is always 0. So we can actually draw a conclusion from the graph that the derivative of a constant is always 0. Now I have the derivative of x, it's 1. The derivative of x to the power of n is n brought down x, n minus 1. This is referred to as the power rule. Moving on, I have the constant multiple rule. That's when I have a constant and I have a function of x. So my constant remains out, and then I find the derivative of the x function. Then I have my sum rule. That's when I have the derivative of f of x plus g of x. I can simplify each function and have the derivative of f of x plus the derivative of g of x. Moving on to my difference formula over here, I have the derivative of f of x minus g of x. The same thing applies here, right? I have the derivative of f of x minus the derivative of g of x. And now at this point, we need to test our knowledge. So I have a couple of examples here that we're going to go over. So here I have f of x equal to x to the power of 6. To find the derivative of this function, which is f prime of x, this is the power rule. So I'm going to have to bring down my 6 and subtract from 1, right? So when I bring down my 6, I'm going to have 6x. 6 minus 1 is what? Is 5. And it's that simple. The same thing applies here. I'm going to bring down my 3 and subtract from 1, right? So here I have 3r to the power of what? Of 2, right? And over here might look a little bit tricky, but we could actually simplify 1 over x squared into one single term. And when I do that, I'm just going to have x to the power of negative 2, right? It's important to know that anytime you have 1 over, that simply means a negative, right? And then the power always follows instantly. So here I'm going to make it of my power rule. The negative 2 comes down and I subtract from 1. So I'm going to have negative 2x, negative 3. And that's it. Over to this question, I have the cube root of x squared. The cube root of x squared could be simplified as x to the power of 2/3, right? Now, in simplifying this, I'm going to make use of my power rule. So my 2/3 comes down and I subtract from 1, right? So now I'm going to have 2/3 x negative 1/3. And that's it. Over to this question, I'm going to find the derivative of each term. So I'm going to have the derivative of x to the power of 8 plus the derivative of 12x to the power of 5 minus the derivative of 4x to the power of 4 plus the derivative of 10x to the power of 3 minus the derivative of 6x plus the derivative of 5. Now, the derivative of x to the power of 8, I'm going to bring down my power and subtract from 1. So this automatically becomes 8x to the power of what? Of 7, right? Now I'm going to bring down my 5 and subtract from 1. So I'm going to have 60x to the power of 4. Why? Because 5 times 12 is what? Is 60. Now here I'm going to have my minus because that's what I have here. The 4 comes down here and I subtract from 1. So I'm going to have 16x cubed. The same thing applies here. The 3 comes down and I subtract from 1. So I'm going to have 30x squared. The same thing applies here. Now, for this particular one, I have x to the power of 1. 1 is imaginary, so let's just think of it like in that perspective. So 1 comes down here, so I have 1 times 6, right? And then I have my 6. Now here I have x to the power of 1 minus 1, which gives me x to the power of 0. It's important to know that any number to the power of 0 is always equal to what? 1, right? So now I have 1 times 6, which just gives me 6. And here I have the derivative of 5. 5 is a constant, right? And it's just going to be what? 0. That's it. So now I can rewrite this to look neater. So I have 8x to the power of 7 plus 60x to the power of 4 minus 16x cubed plus 30x squared plus 6. And this is my final answer. Now, I'm going to move on to trigonometric functions, and I'm going to start first with sine and cosine functions. So I have the derivative of sine x, which is cosine x, the derivative of cosine x, which is negative sine x. In my subsequent videos to come, I'm going to talk more on how this was actually derived. So let's go over this question. Differentiate y equal to 3 sine theta plus cosine theta, right? So now in order to differentiate this becomes y prime, right? And here I'm going to make use of my addition, my sum rule, and also my constant multiple rule. So this becomes d dx of 3 sine theta plus d dx of 4 cosine theta. So I have y prime, the 3 comes out, so I have 3 d dx of, oh actually this should be theta, not x. So I have sine theta plus 4 d theta of cosine theta. So my y prime gives me 3. What is the derivative of sine theta? Back to what I have here, right? It's just going to be cosine theta, right? And then I have my 4. What is the derivative of cosine theta? It's negative sine. So I'm going to have my negative sine theta. So here I have y prime is equal to 3 cosine theta, right? Now, positive times negative gives me what? Negative, right? So now I have 4 sine theta. And this is the final answer. So this is the ending of the video. I hope I have been able to make things easier for those having a little bit of difficulties. In the next video to come, I'm going to talk on more challenging questions and go over the product rule, the quotient rule, and the chain rule. I hope to see you guys very soon. Thank you and have a lovely day ahead.